Here we go, day 18. All right. Say it's all say keys. They even tell you which direction the keys went. Snailfish numbers aren't like regular numbers. Instead, every sailfish number is a pair, an ordered list of two elements. Each element, x, y, where x and y are elements within the pair. Snailfish homework is about addition. Add two snailfish numbers to form a pair from the left and the right. Parameters with the addition operator. Example, blah, blah, blah becomes 1, 2, 3, 4, 5. Sure, there's only one problem. Snailfish numbers must always be reduced. Adding two snailfish numbers will result in snailfish numbers that need to be reduced. To reduce a snailfish number, you must repeatedly do the first action in the list. If any pair is nested inside four pairs, the leftmost such pair explodes. What? If any regular number is 10 or greater, the leftmost such regular number splits. Wow, that sucks. The 9 has no regular number to its left, so it is not added to any regular number. Wait. If any pair is nested inside four pairs, the leftmost such pair explodes. If any regular number is 10 or greater, the leftmost such regular number splits. 765 becomes 76570. The 2 has no regular number to its right, so it is not added to any regular number. Any pair is nested inside four pairs. How is this pair not nested inside four pairs? Seven, 6, 5, 7, 0. 6, 5, 4, 3, 2, 1 becomes 6, 5, 7, 3. What? Split a regular number, replace it with a pair. The left element of the pair should be the regular number divided by 2 and rounded down, while the right element of the pair should be the regular number divided by 2 and rounded up. 10 becomes 5, 5, 11 becomes 5, 6, 12 becomes 6, 6, and so on. Here's the process of finding the reduced result of this. Here's the puzzle input. There's no pluses in here at all. I don't understand why there's a plus written in any of these examples. If any pair is nested inside four pairs, the leftmost such pair explodes. Okay, when we never see this though. Okay, so the input is a list of numbers. What's implied is that there's a plus sign between each one of these things. That's the implication. So you add the first two together, you get a number. You add the next two together, you get a number. Given this example homework assignment, the final sum is this. The magnitude of this number, I don't know what the magnitude is yet. Haven't gotten there yet. So in essence, you surround this thing with that. We have an explode. We have an explode. What is the explode? This is the explode. So during reduction, at most one action applies, after which the process returns to the top of the list of actions. For example, if split produces a pair that meets the explode criteria, the pair explodes before other splits occur. To explode a pair, the pair's left value is added to the first regular number to the left of the exploding pair, if any. And the pair's right value is added to the first regular number to the right of the exploded pair, if any. Exploding pairs will always consist of two regular numbers. Split a regular number. Yeah, I got that. So we have an explode here, right? So we're basically saying that this becomes 0 and 7 because there's nothing to the left of this. All right, and then this needs to explode again because it's 1, 2, 3, 4, 3, 2, 3, 4, 5. It's at depth 5. And so the first regular number is 7, so that becomes 15. And this 4 goes to the next regular number, which is to the right, which is 9. So this becomes 15. Then this becomes 0, 13. So we need to split 15 into 7 and 8. Split 16 into 6 and 7. And then we have to explode again because 1, 2, 3, 4, 3, 2, 3, 4, 3, 4, 5. Here we are again. And then that becomes 6. And this 7 moves over here to become 8. Oh, these rules are just ridiculous. A list of snailfish numbers. Snailfish numbers are each listed on a separate line. Add the first to the second, then add that result to the third, then add that result to the fourth, and so on until all the numbers have been used once. For example, the final sum of this list is this. Okay. 1, 2, 3, 4. Final sum of this list. 5. Because There's no explosions here. Oh, I see. This is becoming this. I really... Magnitude of a pair is 3 times the magnitude of its left element plus 2 times the magnitude of its right element. The magnitude of a regular number is just that number. 9, 1 is 3 times 9 plus 2 times 1, 29. The magnitude of 1, 9 is 21. Magnitude calculations are recursive. The magnitude of this is 3 times 29 plus 2 times 21 is 129. Oh. What's the magnitude of the final sum? Well, I understand the magnitude thing fairly simply. The other one, my head still does not understand. So let's try the magnitude bit. Yeah, whatever. We don't need any data. Let's just do the magnitude stuff. Right, so we'll just do get magnitude of this. Right, here we'll say console, right, magnitude of value is results. Stop it. So magnitude all right, let's start with simple numbers, actually. All right, that one should be easy. I think what we want to do is we want pairs. All right. So we'll start there. We'll do a stack of pairs. Can't really do stacks of pairs, can we? I guess when we look at this, we can actually just do... Yeah, we can kind of do stacks. All right. You stack along. It's fine. For each, let's see, C in the value. If, let's see, switch on the C, all right? If you're this, we want to, no, we don't want to do a for each, we need an index. So while the index is less than value length, valued index. We'll do plus plus because we're going to move forward. So in this case, what we want to do is we want to push a number. All right, so we'll do stack push. Let's see, we want value of index plus plus minus 0. All right, that should get us a long value. I'm not quite sure what I want to do for that yet. In case of the comma, font. It's fine. So every time we see these, every time we see this, we want to left is, no, right comes up first. Right is stack pop. Left is stack pop. Result. I have result up here, please. Okay, so the result plus equals, it is left times 3 plus, let's see, left times 3 plus right times 2. And then we want to push that, do we want to push that result? I don't think we do, right? So every time we see a right, we pop. Yeah, actually we do, because we want that to be a left. Actually, yeah, so this isn't so much a result here. Yet. Right. So we're going to go ahead and push that result. So we'll just, yeah. Whatever. Okay. When we get to the end, so I don't think we do anything with commas. We just ignore commas. When we get to the end, we should say if stack counts not equal to 1, then we're going to do, actually that's probably okay, because we probably have examples here. Do we? Actually, I think we probably always end up with 1. We never have a number that's just multiple lines. Okay, so that's fine. If stack count's not equal to 1, let's throw stack count was stack count. All right, otherwise we return, let's see, final is stack pop, console.write line final turn final. Okay. So 9-1 operation. Yep. Okay. So we failed already once. That's 55. That's here. So we saw something. Okay, that's fine. Oh, you know what? We need to do the same thing on comma. That's why. Right. So the magnitude of 9-1 is 29. That was correct, right? 9-1 is 29. So the magnitude of 1-9 is 21. Okay, so that's good. So this doesn't work. Let's see if we can figure out why. I think we can comment these out and just walk through this, right? Okay. So where's our locals? Busy, that's great. What are you busy with? Okay. Yeah, that's what I thought. You don't know what you're busy with either. Okay, so left. So our stack now has... What are you busy with? Like, seriously, what? Why? Holy shit. Diagnostic tools. Nobody asked for you. Diagnostic tools. You're worthless. All right, so that's a big value. Value. So IDX is now 2. Value of 1 is 90. Oh, wait a minute. Oh, right. Yeah, I'm making assumptions here, aren't I? I think what I want is I can ignore these, right? And then I can throw these down here. Stack count was 4. Oh, okay. That's not what I expected. All right. So we've got an opening brace, right? Nobody cares about opening brace. And we've got a 9. Wait a minute. Why is that still that? What is index? What is value of index? That's a 1. What? Oh, yeah, that's right. Never mind. Okay, so that's fine. And now we've got our 1. So our 1's getting pushed. Except it's a -4. Why? Value of 2. Value of 2 minus 0 should have been 1. Oh, no. This is C. We shouldn't be walking forward. Okay, I understand. So 143. Yep, looks good. 1384. 1384 looks good. Let's take the biggest one. 3488. Okay, so I'm confident that magnitude is doing its thing. All right, so we don't need that anymore. We don't need that, and you can be inlined. So there's the magnitude. All right, solve the problem I knew how to solve. If any regular number is 10 or greater, the leftmost such regular number splits. So we get here, and you're 5 deep. Right? You get here, you're 5 deep, and you see this. What is the right way to parse this so that we can actually tell everything? Is it an inline parse? Do we just walk it? Any pairs nested inside 4 pairs, the leftmost such pair explodes. If any regular number is 10 or greater, the leftmost such regular number splits. What's interesting to me is I don't know if they have constructed the data such that, like, this is obviously pair number 5 in the nesting. But what if it was actually pair number 6? Did they make that illegal? I mean, it's not here in any of the samples. So this adds up to this. This adds up to this. Kind of interesting. So we make assumptions that every number here is already legitimate. That would be why we never see 5, because it takes addition to get to 5, because every number here should already be legal. Okay, that explains that. Okay, so let's do add 2, value 1 and value 2. Okay, we'll do add 2. This is supposed to be our simple example, right? So let's add this. Actually, let's let's add that. We'll add that and that. Okay. So the new value is this plus value 1 plus a comma plus value 2 plus square bracket. I guess we can just call you value. So we need to walk depth count. So depth is 0. Index. By the way, this could have been a for each. We never do anything else with this, right? Index never matters there. Does index matter here? Let's assume not. Right? Switch C. So if you're one of these, then we have more depth. If you're one of these, we have less depth. Otherwise, I think we want to start pushing numbers into our stack. Is a stack the right answer? I mean, it kind of feels like maybe. I suppose it is. Like this whole, you have to look left and right. I don't know if I can do this all at, like, in real time, right? I wonder if it's just a simple string manipulation. Like I see this and I go look for the end of that. So the only reason we'd ever have to split is because we explode. Right, all the numbers come in starting legal. So it's kind of like when you explode, you then have to split. This does look like something I'm going to want to do with an index, because if I'm going to do this right, because if I'm going to do this over and over again, yeah, okay, fine, is value with the index. Okay, so that's fine. Here we need to deal with depth 5. Right. In the case of depth 5, we need the two numbers. Let's say the last open is the index. Okay. So we know the current index is the close. So let's say we want to explode is going to be the value of index plus 1 of last open plus 1 to index. And then we're going to split that. What's the problem here? Oh, right, and I have to put parentheses in here. All right, and then we're going to split that on commas. All right, so that'll give us a left and a right. And the last digit, we're going to need the last digit as well. Commas we can just ignore, right? Actually, what we want in the stack is probably digit locations. Right. So rather than last digit, we want to do a digit locations push of index. Okay. So our explosion rule looks like pairs left values added to the first regular number to the left of the exploding pair, if any, and that pair's right values added to the first regular number to the right of the exploding pair, if any. So we need the next digit is going to be value of index plus 1. First, now we need to know the location. I can't use a link for this. Next digit index is index, while the next digit index is less than value length. If next digit index sub, let's see, if value sub next digit index, this should be a for loop. Alright, the value of the next digit index is greater than or equal to 0, and the value of the next digit index less than or equal to 9. Then we break. Alright. So the left value to add is going to be digit locations count greater than 0. See, left, let's say previous digit index is going to be, if there is one, we're going to digit locations pop. Otherwise, we're -1. So the previous value is going to be previous digit index is -1, you're 0. Otherwise, you are value of the previous digit index minus 0. Next value is going to be equal to next digit index. Oh yeah, you have to come outside the for loop so we can use you. Next digit index equal to value length, then you're 0, otherwise you are the value at the next digit index. Let's just make sure that all of this is working as expected with this. Actually, we're going to use this, right? Maybe this should be an evaluate. We'll do evaluate. Right. And we'll just go ahead and string these things together ourselves. Okay, so this first example, so let's do these simpler examples here for evaluate, right? So this is our explode. All right, so let's go ahead and run this. That was weird. Okay. So first character is going to be open. Yep. So that's going to give us depth. And then that's going to give us depth. Depth of 3. Depth of 4. Depth of 5. So that's going to be a 9. Now I can already see how this isn't going to work, because we're going to need to pop our 2 digits out of here, but that's okay. Oh, and the comma obviously needs to move the index forward. So we don't actually need to evaluate this to explode, right? We can say to explode is going to be value at stack up. What do we call this? Digit locations, right? Digit locations. To explode right is going to be digit locations pop. And then the left will be that one. Okay. So 1, 2, 3, 4, 5. Index is currently 5. So you'll get pushed. Comma gets ignored. 7 will get pushed. So we're here. We should have a depth of 5. We do. So to explode right should be an 8. Oh yeah, we need to. Sure, that's fine. We need to subtract a 0. So that's an 8 and a 9. Then we're going to go look for the next digit. Okay, so the previous digit index should end up being -1. It does. The next digit index is 10. Value length is 21. Okay, so the previous value will be 0 because it was -1. The next value should be a 1. So the next value is, in fact, 1. Okay. So these need to be -0, -0, -0. Okay, so we've figured out the values of the digits, I believe, right? So left is 9. Clear this. Left is 9. Right is 8. Previous value is 0. The next value is 1, and we have its index. Okay. So what do we do next? So we replace this with this. So because we didn't need to go left at all, all right. So then, let's see. If the previous digit index is -1, then what we want is this needs to be left index. This needs to be right index. Okay. So if that's that, then you're going to be the left index minus 2. Skip back 2 of those. Similarly, if the right index, if the next digit index is equal to value length, then the next digit index is going to be the right index plus 2. Skip forward 2 of those. All right, so now the new value is going to be value from 0 to previous digit index plus we have to account for multi-digit values. Yeah, we have to account for multi-digit values, but we'll get there. All right, so this is going to be this plus let's see, 2 explode left plus previous value 2 string. All right, plus, I suppose we could do it this way. Comma, 2 explode right plus next value and then value of next digit index to the end. And next digit index, yeah, because we're replacing that digit. Except I think we need a square bracket here and a square bracket here. I think. Value is new value. Index is 0. So let's stop there. Okay. So given all of this, we have value, and we have new value, which looks to be 9 and 9. So you say 0 and 9. Explode. The pair's left value is added the first regular number to the left, if any, and the pair's right, if any. So how did this become 0? Because the left was 9. Okay, the pair's left value is added the first regular value number to the left of the exploding pair, if any. All right, exploding pairs will always consist of 2 regular numbers. Then the entire exploding pair is replaced with the regular number 0. What? Three and 4 become 7. But where did the 2 go? 9 is no regular number to its left, so it's not added to the regular number. Oh, I see. Missed that part. So what we should be doing here is we should be actually adding the values here. This is left 2 explode left. And then this will be 2 explode right. All right, so then this is the previous, now this, we don't do the adding here. We do this here. Okay. Yeah, I didn't want to run the whole thing. I just wanted to debug it. So there's our new value, 0, 9. We're missing a comma. Right? New value. We're missing a comma. But is that correct? Let's drop you over there. Now the 1 should have gone away. So I think we have to skip the digit and the skip forward past digit and this, right? There's probably something similar that needs to happen here. We just haven't hit it yet. We'll see. In fact, we can probably pretty much predict that, right? Skip back past digit and that. Okay. So there's our new value. 9, 2, 3, 4. Okay. Let's try this. All right. Let's try this and see what happens. All right. Here's our new value. 765. So we are missing a comma in that case. We're missing a comma in that case. So here, let's convert these all to strings. Right? And that can stay like that. But this, we now have to say previous value is comma plus the previous value. And then I don't know, we'll see, huh? All right, so our new value, that is not where that comma goes. Let's see. So we'll put the boxes in here. And we'll take the boxes out of here. So that looks okay. Let's go do this one again. That one looks okay, because we assume the comma's already there. Okay. What's next? This is interesting because you're kind of embedded. Let's see if we get the right answer here. All right, so our new value is 6573, except we forgot a bunch of square brackets. 65, that should have been 70. Oh, because it's not exactly next. Not exactly next. That's interesting. The 3 comes out here. Wait a minute. Why does the 3 come out there? This is 7. Oh, this is 2 and 1. So the 3 actually goes here. Oh, that's not at all what I expected. Okay. So the replacement... So we're essentially looking to replace this whole thing. Wow. Yeah, that's weird. Right, so that whole string comes out. Two has no regular number. We have a 7 and a 0. So we're going to replace that. Wow, I really don't understand that rule. Here, 3-2 is unaffected because the pair 7-3 is further to the left. 3-2 would explode in the next direction. So I'm looking to replace this whole pair. So I really need to know the previous and the next numbers. So you get 0, or you get 7. I kind of want to see this. I know it's there in that form, but it's weird, right? What is the actual logic I want to apply? This is what I'm replacing. So I delete that. This becomes 3. This becomes 7. And I have to put a 0 here because there's nothing there? That's weird, right? Okay, so let me do this on my own here, right? This is what ends up getting replaced, right? So a 7 and a 3. So this becomes 8. And this becomes 9. And then this is empty. So it gets a 0. Does it always get a 0? Not always. Is that what it ended up? 3, 2, 9, 5, 4, 3, 2. That is it. So, okay. So if I'm going to replace that, this explodes. Right? So the 8 becomes 9, and this becomes 0. Because there was nothing. I guess that is the rule. But you have to know that it's 0. You have to know that it's 0. How do you know that it's 0? Like, programmatically, how am I going to know that that's 0? So here's another one. Is it the case that we always end up with zeros? So this is the one that's got to explode, right? So that's that. We immediately replace it with 0, and that with 7. You just replace it with 0? Every time we end up with a 0, and then the added number goes in the new place. But now the split has to happen as well. Okay, well, let's try that logic. So none of this is exactly right. Let's see what's correct. So we've got the right index, we've got the left index. Right? We've got the previous digit index, we've got the next digit index. Let's ignore all of this. All right, you can go there. So now I've got the indexes. So the new value then, if I'm understanding this correctly, is we want so let's do this. Let's do the splits as well. So the previous value is going to be equal to previous digit index is equal to -1. You're 0. Otherwise, you are the left 2 explode left plus value at the previous digit index minus that. Okay. The next value is going to be the next digit index equal to value length. You'll be 0. Otherwise, you'll be 2 explode right plus the value at the next digit index minus 0. So we don't have to worry about the splits yet. We'll get there in a second. So what we want is up to the previous digit, we leave it alone. Then we put in the previous value. Right? Then we put in the value from previous digit index plus 1 to the left index minus 2. Right? Because that's going to skip the, just minus 1, because we want to skip the opening bracket, right? Then we're going to put the number 0. Oops. Then we're going to put the number 0. Then we're going to put value from next digit index, from right index plus 1. plus 2, because now we want to skip over the digit in the right-hand side through the next digit index, through the next digit index, and then we want the next value. And then we want the rest, which is value sub next digit index plus 1 to the end. Now, we definitely have issues here, like this doesn't work when it's -1, that doesn't work when it's the end. So what we really want is, let's do this. Let's say if the previous digit index is -1, then we're going to do one set of stuff, otherwise we're going to do another set of stuff. So here, the previous value, you can just be int, it's fine. So here the previous value is going to be, previous value is this. That's probably the only thing that we need. But if your previous digit index is that, then your previous value is 0. And your previous digit index is going to be let's see, you don't have a digit to replace. Yeah, this is actually the wrong place to do this. We can't just do this as one big giant string. That's the problem. Okay. So let's do this. We'll start with this. Right. If the previous digit index... let's do this. So var new value is an empty string. Okay? So if the previous index is -1, then we're going to do one set of stuff, otherwise we're going to do the other set of stuff. So the normal set of stuff here is going to be new value plus equals this and the previous value. I'm not 100% sure yet on that one. Let me think about the logic here, right? So let's do this again. So here's my logic. My logic is I'm going to slice this out. Right? So I want this. So I always want that. And that is going to be not, right? So in that case, what I want then is new value from 0 to the left index to the left index minus 1. Left index minus 1. No, stop it. So, but here what I want is, in this case, so in, well, I've already fucked up a whole bunch of stuff. Let's go get our sample again. So in this case, where we have previous digits, right? Let's make a copy of this. So we're here, we're going to slice this out, and we have 7. So what we're doing then is we're pulling, my bad. Right, we're going to pull this, right? We're going to pull that, and then we're going to put 7. So we pull that, and then we put 7. Then we need to pull the rest of this, right? So that would be the value from something to something. So the something to something is previous digit index plus 1, right? And then we want to go right up to the left index minus 1. Okay. So that's that. Now, new value plus equals 0. Right, because then we did all of this, right? We're going to skip that. We're going to put in a 0 now. So let's follow along up here too, right? So instead of doing this bottom, we do the top, which is to left index minus 1. So that's going to get us that. And then we're going to put in a 0. Yep, to left, yep. Okay, so then we've got a 0. Now what we need on the other half is we need whatever is between, now we say if the next digit index is equal to value length, we're going to need one thing, otherwise we're going to need another thing. All right, so if you never found anything to the right, then that basically means we want to go, this is my right index. I want to start plus 2 and take the rest. I want to do new value plus equals value of right index plus 1 to the end. Right? Otherwise, I want new value plus equals something computed. And so the something computed, so that's this, and then that does this. And so here we now have a number. So we want right index plus 2 again. So now we want value sub right index plus 2. That was supposed to be plus 2, by the way, not plus 1. To something. So right index plus 2, and then we want to stop at the index of the next digit. Right? So we're going to go to the next digit index. And then we're going to put in the next value. Right? And then we're going to put in the value this is going to be like, this is going to be right. So we got right index plus 2 to there, and so this goes to the next digit index. So we do a next digit index, so we replace that, so we just need plus 1 to the end. Okay. I think that's everything. Okay, let's do the top one first. Okay, let's clear this out. Let's put some watches in here, right? So let's put in, one of the things we could really do here is make the watch window bigger. Watch locals, Sega UI. How about like 12? Wow, how did that not do anything? Is that what that dialog box just said? Watch windows. Oh, it did. It made it bigger. Okay. All right, so we want left index. We want right index. We want the previous digit index. We want the next digit index. We want the previous value. We want the next value. Okay. We want the value and we want the new value. Okay, so we've got... Wow, I put it all the way down here. I actually meant to put it up here. Sure. But we've got our 4 squares. We've got a 0. I feel like I'm going to be missing a comma, maybe? I don't know, we'll see. So the next digit index is 10. So let's take a look at what this is. What are you? Okay, so that's where the comma is coming from. And then we have next value, and then that'll be the rest. So we end up with 0, 9, comma 2, comma 3, comma 4. That's what we're supposed to have, right? Where is my... There you are. 9. Yeah, you can go over there now, because we're using a watch window. 2, 3, 4. Okay, that version worked okay. What about this version? So, you guys we don't need. So because you're that, we should get 7, 6, 5. We should get the square bracket right before 4 with a 7 and then the comma. And now a 0, and now the rest of it. So 7, 6, 5, 7, 6, 5, 7, 0, and a bunch of squares. Okay, that looks pretty good. Got diagnostic tools. I need to uninstall that feature. I never use it. All it does is get in my way and slow things down. Yes, in case you were curious, I can find something to complain about everything. Okay. So this should end up doing the complex version of both, right? And then a 0 and then a complex version, and so we get square, 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 6, comma, square, 5, comma, square, 7, comma, 0, square, 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 comma, 3, comma, 0. Okay, that's not bad. So let's do this. Eval this, please. Okay. So we end up 3280, 3's squares, 9. Okay, so 5, 4, 3, 2. So then we should be able to evaluate that again. Actually, we will evaluate that again just by coming back up here. Although index 0, depth 0, and digit locations clear is all going to be required for this. And then a break. I don't have to do break. We could do else and leave the break there. Okay, so let's do this again. So we come down here to this. We get that. And then we come through again. And we get that. 9, 5, Okay, 9570. Okay, so the only thing that's left is to do splits. And the only time we have splits are here. So next value toString var. So let's do this. Previous value string, previous value to string. Next value string is next value to string. We're going to use these. Okay. The end of this is index is less than value length. Okay. Now, what we need to do here is previous value greater than 9. We need to do something special here. Otherwise, we do that. Next value greater than 9. We do something special. Otherwise, we do that. Right? And something special is a split. So we'll do a split of the previous, shut up, previous value. And we'll do a split of the next value. Right? And so string split into value. We're going to return the divided by 2 rounded down, divided by 2 rounded up. So this is going to be value divided by 2. So square value divided by 2, comma, value mod, see, value divided by 2 plus value mod 2. That'll get us a round up. All right. Why don't you get us a round up? Sure. So, examples of where we need splits. Right. So if we evaluate this, what we should see is we should see a bunch of splits. By the way, this returns value. Okay, so now let's evaluate this. Okay, so we should see, let's do this, right? So the first thing that has to happen here, according to our page, is we should explode it into this. So previous value and next value are still small. 0 and 7. Okay. So our new value should look like okay, looks good. Okay, the next time we come through, previous value and next value are large. They're both 15 and 13. 15 and 13. Right? So we're going to do the explode and the split all at the same time. Right? So the previous value string for 15 should become 7, 8. Oh yeah, we're not looking at here. Previous value string. Next value string. So the next value string is going to be 6 and 7. So we should end up with this. All right, so 4 opens, 0, 7. Oh, you're writing a custom parser. Yes, I was thinking about using Newtonsoft to parse a string. It's just a JSON array. Yeah, that's an interesting idea. Yes, I'm writing a custom parser because, you know, I'm psychotic. All right, so looks like we should end up with 0, 7, 4, 2 squares, 7, 8, comma, open square 0, comma, open square 6, comma 7, 4 closed squares, 1, 1, right? And then we should explode one more time. And we're going to put a return here. We're going to put a breakpoint there. So our return one more time should be this. So we end up with 0, 7, 4, 2 opens, 7, 8, comma 6, 0, 3 closes, comma 8. So that looks correct. Once no reduce actions apply, the snailfish number that remains is the actual operation result. So that should be that. Okay. So I think we have the evaluation of everything done. So now, if we were to have this as input data, this is the next step. Okay. So given the input data, our input data is a bunch of strings. It's fine. We're going to do indexes. Let's start at 1. Actually, let's turn this into yeah, that's fine. We'll turn it into a list. Actually, the array is fine. The array is fine. We're going to start at index 1. Index is less than data length plus index. We're going to say result, which you don't need a temp here, but we'll do it anyway. So we'll evaluate the composition of data index minus 1, comma, data of index, right? And then we should be able to say data of index is equal to the result. And then we'll do a console write line of data.length minus 1. I'm just going to run it just for fun, right? We got, I think, the right answer, right? Bunch of 1s, 2s, 3s, 4s. We throw a 5 at the end, what happens? All right, we throw a 5 at the end, what happens? We get 3, 0, 5, 3, 4, 4, 5, 5. Okay, all good. And then we throw 6s at the end. And we get 5, 7, 4, 5, 5, 6, 6. Okay, that looks pretty good. Now we have the slightly larger example, which should give us a final sum. Okay, so let's take our larger example. Whoa, that's so very wrong. We definitely have weird stuff happening here. All right, let's do it one at a time. All right, let's see where we fall. So every time we get a result. All right, you can all go away. What's data of index minus 1? What's data of index? And what's our result? Okay, so we add that to that, and we get this. Does that look correct? 4 squares, 4, 0, 5, 4, 2 squares, 2 squares, 7, 7, 6, 0, 3 squares, 2 squares, that should be 8, 7, 7. Yeah, so we definitely failed. And like this 0, these zeros that are hanging out here are definitely wrong, right? So let's see where we fall down. Okay. Let's actually just stop here. Take a look at value and new value. Right. So the first explosion is going to be here on the 4, 5. Whoops. Which this 4 gets transplanted over here, this 5 gets transplanted over here, so then this becomes that. So our next, so this is 4, 3, 4, 3, 2, 3, 4, 5. So our next explosion is going to be here with this 4, 5. All right. Right, so this 4, 5 gets exploded out as a 4 over here and a 7 over here, and this got replaced with a 0. So far looks good. So our next explosion, 1, 2, 3, 4, 3, 4, 3, 2, 3, 4, 5, is going to be this 7, 6. So the 7 moves over here. 6 and a 9 became 15, and that became 7, 8. So far, so good. So then this becomes our next explosion, right? 4, 3, 4, 3, 2, 3, 4, 3, 4, 5. So the 7, 8 here becomes our next explosion. All right, so the 7 went over here. This became a 0. 8 and a 5 became 13. That became this. Which means the 6, 7 is going to be our next explosion, which puts the 6 over here, 14 over here, which split out into 14. So 4, 3, 4, 2, 4, 3, 4, 3, 2, 1, 2, 3, 2, 3, 4, 5. So 3, 7 is next. So 3, 7, 3 comes over here to become 10, which gets split into 5, 5. 7 comes over here to become 11, which gets split into 5, 6. So then a 5, 5 becomes our next. No? Is that not it? 4, 3, 4, 2, 4, 3, 4, 1, 3, 4. No, I guess not. 2, 4, 5. So this whole thing, that's kind of interesting, isn't it? This is an explode that happens at 6. Now, there's something in the rules about splitting and exploding. Maybe I shouldn't be trying to split here. Maybe I should just go ahead and put the number in there and then look for extra digit locations here. Maybe that's what I should do. So let's comment this out. Let's use this sample again. Let's use this sample again. All right. And then we'll just evaluate that because this has splits. So let's put the previous value and the next value here. If digit locations try peek out last digit index is equal to index minus 1, meaning we already saw a digit, then what that means is we have a split that has to happen right here. All right. And that means we have a split that has to happen right here at index minus 1. Okay. Let's do this so that we don't push past. Right? So we need to do a split. So we need to do, let's see, var new value, right? It's going to be equal to data. No, is it data? That's value. Value from 0 to index minus 2 to index minus 2. And then the split of something, and then value of index plus 1 to the end. So we need to know what to split. So oversize value is going to be int parse value of index minus 1 to index plus 1 because it's not inclusive. So we split the oversized value. And then we say the value is equal to the new value. Index is 0. Depth is 0. Digit location is clear. Man, I'm sorry. I should hit the mute button. I didn't get to it quite fast enough. Okay. Let's take a look at this. So let's evaluate this. So we're going to start here. Right? So then that gets us 074784911. Looks good. And then that gets us 15 and 13. That looks good. And then it what? It crashed? And then it stopped. That shouldn't be there. That should be here. Okay. So that's okay. 15 and 13 are fine. Now we're down here. Our oversized value should be 15, which gave us a 7 and 8. Good. And then we've got an oversized value of 13, which turns into a 6 and a 7. But yeah, no, I screwed that up. Hang on. I think I'm doing off by 1 here. Busy. Nobody knows what you're busy about, okay? Shut up. Busy. Nobody knows why you're busy. You're just a broken debugger. That's okay. That's okay. That must be wrong. Yeah, so I'm missing a square bracket here on the 7 and 8. So this should have been index minus 1. And what else is wrong? So 7 and 8. 0, let's see, we got the comma, we got the 1 open, 0, 13, 3 closed, 1, 1. Okay, that all looks good. I was just off by 1 on that bracket. And so that's our final value. All right, so now we have 4 squares, 0, 7, close, 4, close, open, 7, 8, close, open, 6, 0, close, 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 open, 8, 1, close, close. Okay, that looks good. That's not what I wanted to refresh. Okay, let's go back and evaluate our real data. That still looks wrong. Okay. Those can go away, though. Okay. All right. Step by step. So the 4, 5 exploded 4 and 5. That looks okay. The 4, 5 here exploded to 4. Actually, I kind of want to walk through these as I'm doing them. Right. So we've got here is this 7, 6 goes a 7 here, a 0 there, 9 and 6 becomes 15. And now we have 15 to deal with. So 15 became 7 and 8. So then we've got 7 and 8 now have to get dealt with. So the 7 comes here. We've got a 0. And then 13 goes there with 3 closed. That looks good. Okay. So 13 becomes 6 and 7. 6 and 7 is going to be our next explode. We can just kind of tell. So the 6 goes here. All right. And then we got 3 closed. We got a 14 over here. Looks good. And then 14's are oversized, so that becomes 7, 7. And then 3, 7 is our next, apparently. Oh, we're trying to explode before we reduce. Is that what we're supposed to do, though? It might actually be what we're supposed to do. I don't remember. If any pair is nested then exploded, if any regular number is 10 or greater, do splits. Once no action in the above list applies, the snailfish number is reduced. During reduction, at most one action applies, after which the process returns to the top of the list of actions. The split produces a pair that meets the explode criteria, and the pair explodes before other splits occur. Split produces a pair that explodes. Then the pair explodes before other splits occur. Yeah, okay. So that's right. So we're now... The result was something that needed to be exploded before the split. It's weird, but it is what it is. So we've got a 0, and then this 7 is going over here for 11, right? So we could end up with numbers that are bigger than 2 digits, is really what it amounts to. It's probably what's going to happen here, if I'm predicting things. Nope, so we split our 10 into 5, 5. Stop it. But we have explosions that are supposed to be happening before splits. So we can't just start splitting right away. We should always try to explode first. So what we do is we walk the whole thing and we look for yeah, so we don't do this here. All right, I get it. I get it now. This is something that has to happen later. Now we look for splits by checking for paired up digits. So what we really want to do then is we want to say last digit index. Did we already use that name? If we did, it's in somewhere else. So, okay, so the last digit index is going to be int max value. Okay, and then we're going to say while digit locations, while true, while digit locations count is greater than 0, right? Digit index is going to be digit locations pop. We're going backwards, so we're going to say if digit index plus 1 is equal to last digit index, then we need to do all of that. And we need to do all of that. The interesting thing about this, though, is that so this is going to be digit index because this is the first digit, right? First digit. So we want first digit minus 1. Wait a minute, we want the first digit to the last digit. So we want digit index to last digit index plus 1. You're going to be 0 to digit index, and you're going to be last digit, you're going to be last digit index to the end. And then we're going to have to basically return evaluate of the new value. All right, because we're out of the loop here, we can't just depend on the loop to do it again. All right. So I think we're confident in all of this doing the right thing. Well, you know what? I'm going to leave the breakpoint there anyway, just so we can watch it. And then I want to see the splits. Okay. So we move the 4 over, we move the 5 over, we move the 4 over, we move the 5 over. Looks good. We move the 7 over, we move the 6 over. Looks good. We move the 3 over. We move the 7 over. Okay, looks good. Oh, except now we have this problem of we don't know how big this is, right? So if we were to say value of previous digit index, see, now we have to know how big everything is. Value of 0 to left index plot minus 1, because these are going to be now potentially multi-digit values, right? All right, to explode left should be 11, but it's really 1. So that's really what the problem is. Now, this all assumes single digits. Okay, so if we get to the end of this, then what we really want to do is, rather than making assumptions about this, we want to know we really want to know where the last open is, right? All right. Get me to the 11 version. I think this is the 11 version. I don't know that I care about the left index and the right index. I think what I care about is last open. So what is value of last open to index? Right, that's what I care about. My bad. So rather than trying to pop the numbers out and look at them one at a time, I did correctly identify that this is where I am. I don't actually care about the digit locations anymore, right? Oh, I do. Because I need to go backwards. Okay, so pieces is going to be a string split. Now, so I want value of last open plus 1 to index, and then I want to split that on the comma, right? And then I want to say to explode left is going to be int parse. of pieces sub 0 to explode right is int parse pieces of 1. Now I need to try and find the previous digit index. Previous digit index is -1. That's where we'll start. Right, and then digit index is going to be able, so we'll say while digit locations count is greater than 0, you're going to be a digit location pop. If you are less than the last open, then you're it. And we're done with this while loop. Right, so what did I do wrong? So, yeah, so left index is actually last open. So this is 0 to last open, because left index was one more than that, right? Then this is again last open. And then right index is going to be index plus 1, I think. All right. Okay. Let's go ahead and set a breakpoint there. All right. So right now, I want to look at 2 explode left, 2 explode right, 4 and 5. Okay, so 4 and 5. Previous digit index should end up at 0, so we'll pop once, we'll pop twice, and that should be it. And then we'll say value at previous digit index. That'll be the 0. Okay. All right, so then that gets us there. That gets us there. That gets us there. 3 and a 7 make the 10. Here's the 11 and the 3. So 11 should end up. All right, let's go ahead and do this. All right, so the 11 should end up there. And the 3 should become a 9. Okay. Now we've got 9 and 3. So the 9 should go there. All right, and the 3 should make 11. Okay. And now we've got 11 and 8. So the 11 should go there. And the 8 becomes 0. And now we've got what? A 4 and a 0? Oh, that's an entirely new thing. We missed our splits. How come we didn't have any splits? Maybe we did have splits, but we're already evaluating them. I don't know. So I think that's right. So now we want last digit index, digit index. That's okay. So that's the 0, so we should be back to 46. Oh, we're forgetting to set. Forgetting to set it, of course. So we should end up at the 11. No, we should end up at the 5th. No, we're going to go backwards. I don't want to go backwards, do we? Shit. Because it says to go left first. Can reverse the stack. Okay, good. So then... So this should be this, and then this should be digit index. This should be this. This should be this. I think. Okay, so we got all the way through. We should hit the 15. What the hell is going on here? That was very wrong. Okay. So we should hit the 15. So digit index, first digit index. Does reverse here actually return a new stack? It does. Because it's linked. Let's do this then. For each var digit index in digit locations reverse. So that's 4. That's not going to hit. That's 6. Then we should have 9, right? Or 10. Then we should have 12. We should have something like 17-ish, maybe? 18. So that's not going to hit, because that's 20. Now we should have like, what, 23, 24? 24. And there's 25, so that hits. Our oversized value is 15. All right. $15 splits 7 and 8. We run the explosion. Okay. So then that splits 13 into 6 and 7. We have 80 here? Really? Did something really bad happen? Because if we're going to have numbers that big, then we definitely have an issue. This has to be longer. 15 got split into 7, 8. The rest of this looks okay. 7, 8. 7 moved over here. 8 and a 5 became 13. So this should be our 13, right? What is our oversized value? It's 13. 13 got split into 6 and 7. So there's 4. 6 and 7 should go 6, and this should become 17. And it became 80 because this doesn't look for multi-digit, multi-length numbers either. Right. So we look for the previous digit. We look for the next digit. End index is going to be the next digit start index. The next digit end index is less than value length. Next digit end index. And that's what we want to get out, with either being less than 0 or greater than 9. That's when we want to find the last index. Previous digit index is another problem. Where do we get the previous digit index from? Here. Except we don't know that that's not also multi-digit. Ouch. PN doing this with the Newtonsoft. Starting to feel like I should have done that. That suggestion from a half an hour ago. So again with this, if this is exactly equal to that minus 1, otherwise we can break. This is probably just previous is equal to digit. Okay. So previous digit start index, previous digit end index, next digit start index, next digit end index. We should actually put our (14) and 77, so value length is 77. Wasn't that interesting? That's the 0, because we're doing the 4 and a 5, so that's the 0. That's dumb. So it's 4 to 4, but that's 14 to 15. Let's actually get them lined up correctly. This is okay. We want this to be +1. This will be 4 to 4 and 14 to 14. Plus int parse of value of previous digit start index to previous digit end index +1. And then same thing here. This will be int parse the value of next digit start index to next digit next digit end index +1. All right. Previous value, next value, 4 and a 5. Okay. So there's that. And we split 7 and 8 into 15. And then we're going to have to split 13 into 6 and 7. Whoa. Whoa. 17 was correct. But so we want to go from 0 to the previous digit end index, and then end index, no, previous digit start index, and then end index +1. Next digit start index, and then next digit end index +1. Okay. So that's going to find 15, splitting into 7 and 8. So the 7 went here, and that turned into 13. So that's going to find 13. So that puts 6, 7. 6 goes here. The 7 goes there to 17. Nice. Okay. And then this 11 gets split into 5 and 6. 5 goes here. 6 goes there. 14 becomes 7 and 7. Nothing needs to explode, so the 15 becomes 7 and 8. The 19 now needs to get, nothing exploded. Out of the 7 and the 8 went there. So then we split the 19 into 9 and 10. So then that became 0 and 10, and then 10 becomes 5 and 5, and that becomes 5 and 0. Now we have an entirely new set of numbers. Okay, that is a sensible number now, right? The end result of all of this becomes open, 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 8, 7, close, open, 7, 7, close, close, open, open, 8, 6, close, open, 7, 7, close, 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 open, 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 0, 7, close, open, 6, 6, close, close, open, 8, 7, close, close, close. Check if the right answer to snail test only checks the magnitude of the final sum. So now we just need the magnitude of the final sum. So given this homework assignment, okay, given that homework assignment, we don't need to write these. What we need is the, I mean, we can write it, it's fine, but we need the magnitude, get the magnitude of this result. 4140. 4140. Get your puzzle input. See how bad it gets. 3551. Okay. Hope for the best. Notice the second question on the back of the homework assignment. What is the largest magnitude you can get from adding only 2 of the snailfish numbers? Note that the snailfish addition is not commutative. That is, x plus y and y plus x can produce different results. So again, considering the last example, the largest magnitude of the sum of any 2 snailfish numbers in this list is 3993. So here's the homework assignment. Is that the same homework assignment? Doesn't look, oh yeah, it does look like it, okay. So what we're looking for then is the largest magnitude you get from adding any 2 numbers. Largest, 0L. And what we'll do is index is less than data length minus 1, double plus index, results, evaluate this. Except we're going to do index 2. I'll actually do the exact same thing. We'll do the whole round with index 2. And then we'll say if index is not equal to index 2, then we're going to evaluate index comma, index 2. The magnitude is to get the magnitude of the result. If the magnitude is greater than the largest, then the largest is the magnitude. Return the largest, and go. Now what? 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 Semicolon where? Oh my god. Okay. 44.95. All right, 44.95. 39.93. The largest magnitude of the sum of any two snailfish numbers in this list is 39.93. 39.93. 41.40. 41.40. 39.93. So we do every item against every other item when they aren't the same. So let's do this. Let's console write line. Data index plus data index 2 equals result console write line magnitude is magnitude. So I don't see anything that starts with 2. What am I missing here? We're not manipulating data in any way. Nine. Okay, let's make the print simpler. We'll say index plus index 2 equals that magnitude with that result. Data of index 2. So you think you're telling me that square 2, which should be 8. All right, 0, 1, 2, 3, 4, 5, 6, 7, 8. And 0. All right, so 8 and 0. I get 44.95. Did I get the wrong answer? 8 and 0. Ends up being, wow, these answers all look really close to the same. 7, 7, 7, so this is wrong. 7, 8, 6, 6. mean this is 8. All right, 0, 1, 2, 3, 4, 5, 6, 7, 8. I mean, I get the biggest magnitude, but I got the wrong answer. And this is definitely 0. How did I get the right answer before and the wrong answer now? All right, forget all of this. Evaluate that, comma that. Whoa, that's the right answer. 7866 60, right? Okay, cut it out. Killing me, Smalls. 7866 60 77 78 88. That's the right magnitude. That's the right number. Result. Magnitude is get the magnitude of the result stack count was 2. Stack count was 2. What? Wait, what? Okay, U and U. 4, open, 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 7, 8, close. Open, 6, 6, close, close. Open, open, 6, 0, close. Open, 7, 7, close, close, close. Open, 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 7, 8, close. Open, 8, 8, close, close. Open, open, 7, 9, close. Open, 0, 6, close, close. Whoa, where did this last close come from? How did I what? How did that happen? That's not the right answer. Did I forget to close this? I bet I forgot to close it, didn't I? Ha! I forgot to close it. I'm a dummy. 39.93. 39.93. Okay, then what the hell is wrong with my part 2? I don't understand. What is wrong with my part 2? Result is to evaluate data of index, data index of 2. Magnitude is to get the magnitude of the result. Index plus index 2 equals magnitude with this result. Open square, data of index, comma, data of index 2, source. Okay, we'll kill you, and we'll kill you, because all we care about is index is 8, index 2 is 0. Have they not already been evaluated in line 19? Yes, they have already been evaluated in line 19. But not really, because that is... So part 1, you go all the way from top to bottom and evaluate the whole thing, one after another. Part 2 is you're basically just picking all the pairwise combinations and evaluating that alone, and then getting the magnitude of that. So the answer is no. All right. So console Right line, the source. Console right line, the result. Console right line, the magnitude. So the source is wrong. Wait a minute. How's the source wrong? Is part 1 screwing up the data for part 2? It is. Holy crap. All right. Well, I'm going to go undo this. Use my real data. Use my real data. Get a real answer and submit it. And then I'll figure out what's happening here. Okay. Why is... Is it because I'm using this syntax? This slice syntax? Is that this range syntax? What does a string with a range return? String x. So if I do an indexer with a range, like where does that coming from? It's not even here, is it? $10 says that range is doing not a copy, not a substring. Right. So let's bring this back. Let's substring everybody. Okay. So you need to be a substring. Right. You need to be a substring. You need to be a substring. You need to be a substring. Wait a minute. Yeah. Right. You need to be a substring. Man, that's totally evil if that's what's happening here. Substring can be simplified. Like hell it can. Those are indexers. That's okay. Is it going to work now? Input string was not in the correct format. What? 67. Okay, I did something bad here. Oh, you were last, weren't you? How is that not the correct substring? Oh, substrings are lengths. Oh, God. Okay, I need to undo all of these. Wow. I have an easier solution for this because I'm seriously running out of patience with this. Where's my builder? Damn. $45.55, was that my real answer? Yeah, it was. Okay. But if I turn you on, 45.55 is going to be wrong, right? Wow, and it took a long time to figure that out too, because the data was screwed up. There's my fix. We're going to read the data. What's your damn problem? What happened there? That was weird. 35.51, 45.55. 45, 35. Okay, good. That is all I'm going to do with that. And I am not going to try and fix the substring problem, because it's 11:30 a.m. 11:30 p.m. Wow, already so tired. I don't even know what friggin' a.m. or p.m. anymore. Okay. Actually, did a lot better than I thought, given the fact it took me 2 hours and 18 minutes to do the first half. First one in my small group. Jumped back up into third place, but probably not going to stay there. I don't know. We'll see. I'm expecting Zero Width will probably pop back over top in front of me. Depends on how many people finish it. All right. Cool. Cool. Yeah. Did I do this the hardest possible way? Maybe. The suggestion at 10:30 of maybe I should have just parsed it with a JSON parser is kind of an interesting idea. I don't know that this is 100% legal JSON, but I feel like I probably would have struggled more with the JSON parser than writing one by hand. So, yeah, there you go. That's it. 2 hours and 40 minutes. Kind of a long one. Thanks to everybody who stuck in there with me, and I'll see you all tomorrow.